Hi, welcome to Assignment 7 Overview. This is a hefty assignment. One of my goals behind this assignment is to prepare you for the course project, where you're going to be challenged to actually create a fully functional application using the Circuit Playground Express. That might sound a lot more intimidating than what it is, and hopefully this assignment will show you how anything's capable, as long as you take small steps. And with learning how to create functions, hopefully you see as long as you break it down into small steps, small functions that you can then piece together into a bigger program, the project becomes manageable. So in this assignment, we're going to recreate a toy called Bop It, which challenged the player to accomplish certain tasks with the toy in order to win within a certain time frame. So some of the things that we can do with the circuit playground to kind of mimic this idea of different tasks, we could challenge the user to tilt the circuit playground forward, backwards, cover up the light sensor, press the left button, press the right button, press both buttons, and all with different cues. Again, they don't have an output in terms of like a screen. So we'll use the NeoPixels primarily to kind of signal to the player what task we want them to complete within maybe 2 seconds. In addition to these basic functions for the challenges, we're also going to create a couple of other functions to kind of handle the game. The first one's the obvious one, start screen, and then we have a game over screen. This is going to be a kind of like the main controller, the play function. This will control which one of the challenges the player is currently playing. And then we have a game update. The game update will keep track of the time, and it'll also keep track of whether the player has won or lost. Again, right now you might be feeling overwhelmed with all of this. During the course project, I'm going to help you map out what functions you need for the particular application you want. What I'm expecting you to be able to do is kind of like what I want you to do with this assignment, is that once you have this big picture idea as to what you want the application to do, and we've broken down what are the different tasks that need to be accomplished for this product, then you actually code it. So scrolling down a little bit more, again, I'm not going to read this to you. I have provided you a kind of like the template, the base code for the project, that if you really wanted to kind of see if this works, once you're done with all the different functions, you could kind of just copy and paste it into this little code, and it should work. So let me review a little bit some of the things that you have here, because you'll probably want to use them in the task that you're going to be challenged with later on in the assignment. So we got 4 variables. Task complete, which is a Boolean. It's originally set to false. Task complete is meant for like each of those little games. Did the player tilt the circuit playground forward in enough time? Did they cover up the light sensor? Did they press the left button? So when the player completes one of those tasks, this becomes true. And again, that's one of the things you're going to have to do in one of the tasks. Game mode. This is controlling which part of the game you're in. And this is pretty much straightforward. Just kind of skip down a little bit. You'll see you essentially only got 3 types of game mode. You're either in the start, you're in the play, or it must be game over. Okay, so that's the whole purpose of game mode, to kind of switch between those different stages in your game. Current task is pretty much just like it says. Which task are you on? Which one of these, kind of scrolling back up, which one of these games are you playing? And I believe there's 6 of them. There's 6. So current task will range between 0 and 5, representing each of those tasks. And then task completed, this is how many of those tasks you have completed. So this is going to play a crucial role in deciding when you win. Because once you've accomplished, let's say, 10 of those challenges up top, all produced in random order, then you'll have won the game. And we've seen this variable before, t. This is going to be our own internal variable, t, for time. So these are your variables. Very important. You're going to use them throughout the task down below. Something else to kind of help you out a little bit and just kind of show you how when you create a function, you can reuse it. Once you've created something in a different program, it might be useful in another program. So one that I think will be useful for you is the color all, because you are going to be challenged to color all the neopixels a particular color. I don't want to see you use a for loop. Reason being, I have given you the code for color all, so simply use it. And if you recall, color all needs a red, green, and blue, and it will color all the neopixels for you. Another one that you're going to need to use in this, actually, I'm trying to think, is pressed. I'm sorry. Okay, so is pressed. So is pressed was one of those really tough, challenging tasks in assignment 6. I went ahead and gave you the code, which is simply I create an array with all the valid recap positions. I create a loop to go through those positions, and if at any point any of those recaps is bigger than 300, then I return true, meaning that somebody has pressed one of the capacitive touchpads. If for some reason we go through the whole loop, all these positions, and none of them read over 300, that means we mustn't have pressed one, and then we return false. Please use this as part of your challenge, and I think this is going to be used in your first challenge. So what else we have here? Nothing special in the void setup, and here's your void loop, which we've already talked about. So what I want to do is I want to kind of go through each of the tasks and maybe give you a little bit of hint, maybe give you a little bit of a starter code on it. All right, so let's get to it. Create a function. So I'm pretty sure all these functions are going to be void, meaning you won't see the word return in any of these. Remember, return is one of those words you look for when you create a function. The other word you look for is the word accepts. Again, if you don't see any of those words, then your function name becomes pretty simple. So I'm going to help you out with the first one. So create a function, tilt forward. We don't see the word return, so that means we're going to return void. So I know it seems like you're not returning anything, but yeah, you have to put a data type. Well, if we recall, void is that data type that signals we're not returning anything. Next thing is tilt forward. And because this doesn't accept anything, then we simply leave it blank. So tilt forward, which sets the color of the top 4 neopixels to green. If the user tilts the CPX forward, then set the variable task complete to true. Again, there's a lot to be said here. Again, take these small tasks slowly. So the first thing they want us to do is let's set the top 4 neopixels. So here's where you can't really kind of get away from it unless you decide to create another function. You can't use the color all for here because we're not coloring them all. We're only coloring the first couple of ones. So we're going to do a set pixel color, and we need the top ones. So it's going to be 0, and what color is it? Green. So we do 0, 255, 0. That's it. And we're going to have to copy and paste this a couple of times. This is one, if we wanted to, we could create a function called color. Hint, hint, hint. I would not object to that because you're going to have to use this a lot. You're going to have to use this in this task. We're going to have to use it in that task, and so on. You can actually use that other function from assignment 6, which allowed you to actually specify the color of it, the name of a color. Again, but I'll leave that up to you. So this is the basic code. So we need 0 and 1, and then we need 9 and 8. This would accomplish getting the top 4 neopixels green. The next thing we need, and one of the things hopefully I'm be demonstrating to you with this first task, this is basic knowledge. With the exception of the idea that we stick it in a function, the stuff inside the function, stuff you've learned. So let's take a look at the next part. It said if the user tilts the CPX forward. All right, so that's ones where you're going to need to do if. Now I'm going to avoid creating a variable I know a lot of you from our discussions, you were comfortable with the whole my variable, but if you decide to do that, then you actually have to create the my variable and set it equal to what's called the circuit playground motion y. Now, because we're only going to use this once, to me, anytime you're going to use something once, it might just benefit just to do it, not create extra work for you. I typically only create variables if it's something I'm going to end up using more than once, or if it really is required for the readability of the program. But for this one, I think we're okay. So we'll do circuit playground motion y, and we're going to check for it to be, crossing fingers, positive. I always forget which way it is, but we're going to leave it at that. If it ends up being the other way around, you can modify it. And again, you'll notice that when you go to test your program. So if the user tilts the CPX forward, okay, that's this part right here. So one of the things, hopefully you start to, well, you're going to end up practicing a lot in this assignment, is reading the scenarios, reading the instructions, and then connecting it to code. So if the user tilts the CPX forward, well, that's this statement. The next part, set a variable task complete to true. Well, that was that first section where I told you about those various variables. You're going to play around with task complete a lot. So task complete equals true. That's it. That's your first function. Just going to clean it up a little bit. Okay. And I think if you figured this part out, you could probably figure out the other one. Because the only difference here is that it's the bottom 4 neopixels. So obviously these positions are going to change. And because we're going to be tilting backwards, the sign is going to change. So these are very similar functions, but they are separate. And you'll see that with some of the other tasks where I'm challenging you to create more than one function. Please remember, functions don't go inside of other functions. I've seen students do this. I'm not sure if it's because of misunderstanding or laziness. You do not put a function within another function. Don't put these functions inside the void loop either. Again, these are all on their own. They're all equal levels. So your next function would start right here, right after that one. Okay, so hopefully you understand task 1. Hopefully you can complete it. Let's go to task 2. Okay, so task 2. Okay, so create a function, blackout, which sets the color of all the neopixels to white. If the user reduces the light level below 20, set the variable task to complete. Okay, so I'm not going to show you this one. Reason being, the code is very similar to the ones from task 1. The difference here is, I would highly suggest you use the color all function. Matter of fact, I want you to. Don't create the for loop to color all the neopixels white. That's the purpose of the color all function. Let it do its job. Okay? We created it. Let it do its job. So in the void blackout, use the color all with the right number sequence to create white and color them all white. Now let's talk about the if statement. If the user reduces the light level. So in a similar fashion, I would ask you, obviously it's an if statement. Obviously it's something with the circuit playground. Hopefully you remember how to get the light level from the sensor and check for it to be below 20. If it is, look what you do. Set a variable task complete to true. Same code, which is why I'm not going to type it for this one. You can do this one. All right, let's go to task 3. Again, might look a little beefy because it's like, oh my God, it's so long. But that's because I'm asking you to create 3 functions. So the first function, left press, which sets the color of the left 5 neopixels to yellow. I'll leave that one up to you. You could use a for loop for this, or you can manually do it with 5 circuit playground set pixel colors. That's up to you. If the user presses the right button, and hopefully at this point, obviously this is an if statement. You know how to do circuit playground, right button. The only thing that's not here is obviously you have to compare it to something so that it turns out true. And if you're one of my CS students, I would challenge you to think of it like this. A value of 1 is true. A value of 0 is false. So you don't necessarily have to do a comparison there. Think about it. So anyway, so you create the if statement, and then you can see here task complete to true. Same idea. So in all these functions, it's about completing the task. So if the user accomplishes the if statement by either pressing the right button, lowering the level of the light to below 30 to make it dark, then you set the task to complete. So hopefully that's starting to make sense as to what the purpose of all these functions are. This one's identical, except that you use the other button. The both press, that one might be a little tricky. So there's two ways of handling this one. The first one, and I'm not going to cover the first part, sets the color of every other NeoPixel to blue and yellow. I'm going to leave that as a task to you how to figure out. You can use a for loop. We've done something like that. If you guys remember, guys and ladies remember, we did the red, green, red, green, red, green. You could definitely use a for loop to do blue, yellow, blue, yellow, blue, yellow, or you could just manually do it. Honestly, at this point, I'm just looking for you to accomplish the task. The efficiency on how you accomplish it, that's up to you. So now the if statement says, if the user presses both the left and right button. So that's the challenge here. How do you do that? So if you're familiar with the AND operator, then use it. Again, I know I haven't taught that to you in class. I do plan to create a video. I'm not sure if I'll have it up by the time this assignment is done. But there is another clever way of testing if the person pressed both buttons. Remember, when you press a button, you get a value of 1 back. So if the person presses both buttons, that means we got 2 1s. A clever way of figuring out if the person has pressed both buttons is to add the value of the right button and the left button together. Because if the person pressed 2 buttons, then it's a 1 plus a 1, which equals 2. And that would be an easy way for you to check in an if statement without the need of the AND operator that we haven't discussed. Okay, so this one might be a little bit challenging for you, but please listen to the clue I just gave you, that if you simply add the value of both the left and right button together and it equals 2, then the person must have pressed both buttons. So moving on to task 4, what's this one? Okay, so at this point we have completed all like our challenge tasks. Now we're going into the functions that kind of manage the program. So we want to create a function start screen, which sets all the NeoPixels to orange. Okay, here, definitely use the color all. And just go online and figure out what are those RGB values that you need in order to make orange. If the user presses any capacitive touch, please, at this point, I want you to use that isPress function that I provided you at the beginning. Don't try to figure this out. Simply use the isPress function. And I'm going to go up for a second, just to kind of show you the beauty of the isPress function. There's nothing special you have to do there. isPress returns a true or false value. So isPress can be used in the if statement to check if the person pressed any capacitive touch. You don't have to do any of the code. I have done it for you. The only thing you have to do now is, where are we? This is blackout. Start screen. The only thing you have to do is use the isPressed in the if statement to check if it's true. If it's true, it means the person pressed the button. So, assuming you get the if statement correct. Again, and with all these challenges, please try your best. Because I'm not looking for something that you're actually going to compile and upload to your circuit playground, I'm more looking for the different pieces that you understand. And up until now, hopefully you realize it's a lot of if statements. And if you remember the name of the course, it's Information and Intelligence. So we're really hitting the intelligence part. I mean, that's how we're going to make this circuit playground smart. to have the ability to play a game with us. I don't want to overshadow the information part. All along the way, we're talking about information. The information is part of each of our if statements. The capacitive touch, that's information. That's whether the person pressed those capacitive touch pads. So again, this is the final assignment, really. You're not going to get it. You might get one more silly assignment after this. But in terms of covering programming concepts and your understanding of circuit playground, this is the one that's bringing it all together. This is the one that's showing you why the course is called Information and Intelligence. Okay, so I diverged again. Set a variable game mode to game. So this one is pretty much like all the other ones, except that just set in a different variable. Okay. The game over, which sets all the NeoPixels to green. Okay, good. So that's another one. Use the color all with the values for green. Remember, color all is supposed to color them all. I don't want to see a folder for that. Might as well use the color all function. If the game mode is when. So I jumped the gun a little bit. So if the game mode is when. And I'm going to write a little piece, a code snippet here. This actually goes inside the function game over. Again, I'm not going to write the function. You should be able to write this. But just kind of show you how you read this. So if game mode is equal to when. It's that easy. And that's why up top, I made a statement, don't overthink the problems. Please read them. One of the things I've hoped that you've started to develop is that programming is an extension of our natural language. If you read a certain way, talk a certain way, the code just flows out. And hopefully you can see here, if game mode is when, we're going to color the NeoPixels green. So I'm actually going to finish this little piece off here just so that you can see how the color all is being used. So color all needs 3 numbers, so there's no red. We'll do all green and 0. That's it. That's all you got to do. Now, anytime you see the word otherwise, that implies the word else. Okay? So when you see the word otherwise in conjunction with an if statement, that means it's an else. And I'm going to finish this one off only because I don't think it's too challenging, which is 255, 0, 0. Okay. So this is your win-lose situation. So if game mode is equal to win, then we're going to do it green. If it's not win, that means the person lost, which means we're going to make them red. Okay. Again, take this approach with all of them. Up until now, all these tasks have just involved just doing simple if statements and simple outcomes. So let's scroll down a little bit, and let me just get rid of this for now. Oops. I'll definitely have to clean this up. Okay, task 5. Task 5 might be the frightening one. Like, oh my God, look at all the things that he's having us do with task 5. But if you realize with all these tasks, I've pretty much given you the code. I've just written it in plain English. So let's take a look at it. So create a function play. I'm not going to show you how to do that. That's up to you. Use the following to guide. So if current task is equal to 0, call left press. Okay. So if current task is equal to 0, that's it. That is it. And then we'll do a call left press. Well, the way you call left press is left press. This is referred to as calling a function. And that's what you're doing. Hopefully you realize all the other ones are the same thing. All you do is just change the number so you can easily copy and paste. I want to show you something else connected to this, that this idea of if statement to kind of decide what to do based off a variable is a common thing to do. And you saw that first up here in the base code. So if game mode's equal to start, do this. Else if game mode's equal to play, do this. Again, in terms of the game, we only have 3 modes. But in terms of this task, which one is it? 5? Task 5, we had a little bit more, but it's still the same idea. Now, even though I didn't write the word else if, I challenge you to do it like that, the same way I did it in the base code. Could you do this as independent if statements? Yes, you can. It will totally work. But for efficiency purposes, once the computer decides that something's a certain task, there's no need to check the other ones. So again, I'll leave it up to you to see what you write. The last if statement, please read it carefully. So if task complete is true, just code it exactly the way it sounds. Assign current task a random number. So assign, that's making current task equal to something. And what am I going to make it equal to? A random number from 0 to 5. The idea here is that when the player completes a task, you want to give them another one. And the fact that it's a random number from 0 to 5 is that the next go around, they'll get a different task. Maybe. Again, random numbers are random numbers. The person might have the challenge of pressing the left button 3 times. Again, we don't know. But that's the beauty of this game, is that, in a quick time frame, the user's gonna have to figure out which task. So the user's gonna have to practice this a little bit. They're gonna have to start associating lights with tasks. Now, I can't remember. I think we had a couple of psychology majors in the class right now. And hopefully you could kind of, I don't want to say conditioning. We're not doing Pavlov's dog. But the idea that eventually the mind is going to get used to seeing a color and then associating with a particular task. So, diverged there a little bit. And then the last thing, we have to increase the task complete. So yeah, every time they complete a task, we want to increase task completed, which if you remember, start off at 0. So hopefully you remember how to increase a variable by a number. We've definitely done a lot of that. And then the last thing is simply to pause the program for 900 milliseconds. Remember, use the delay function for that. I think we're close to the end. Okay, game update. So again, hopefully one of the things you're seeing with all of these, I've given you the algorithm. It's more for you to kind of, read the algorithm, change it into code. And also to kind of inspire you that, you can do this. You can have very sophisticated programs composed of just smaller pieces that you tackle one at a time. Programs are definitely not something that you tackle all in one shot. So when you go to do your course project, I'm going to challenge you. I'm gonna really kind of push you to kind of create something, but I will help you. I'm not going to send you out there and then leave you out there. I'm going to try to help guide you into what the smaller tasks that you need to accomplish are in order for you to complete the whole product. Okay, so let's go back to task 6, the last task in this assignment, which is the game update. So right there, increase t by 1. Again, we learned this early on. You know how to increase a variable by a value. That's that accumulator. If task completed is equal to 10, again, hopefully at this point you're realizing, wow, it's a lot of if statements. Again, going back, that's the intelligence part. That's how we make a program, a device smart. So if the person completed 10 tasks, we're going to set game mode to win. There you go. Okay, so now we've won. If task complete, now these two variables look similar. They're not the same one. This is not a typo. Task completed is a number. Task complete is a Boolean value. So if the person has completed or has complete the current task, then we're going to set t back to 0. Reason being, this t variable is kind of like our counter, our timer, in that I'll go to the second part of the if statement, or this particular one. If t is greater than 20, set game mode to lose. So the idea here is, as the loop is going, t is increasing. If t at some point gets to 20, then the player has taken more than 2 seconds to complete the task. If it's taken them that long, then game mode will be set to lose. But let's say they haven't. Let's say they actually completed the task on time. Then at that point, we're going to set t back to 0. Okay. Now, what else? Otherwise, check to see if t is greater than 20. If t is greater than 20, blah, 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 blah. Okay, so this one might be a little bit challenging, but again, read it. The instructions are there for this. If you put all of these together, and yeah, I think the extra page is just because I've kind of written stuff and pushed things down. So, all right, good luck. If you have any questions, please email me. This is a hefty assignment, but hopefully this video will help guide you through each task.